Right now, you are surrounded by invisible matter and energy. You can't see it. You can't touch it. But without it, galaxies, stars, even life itself would not exist. Welcome to the greatest mystery in science, dark matter, and dark energy. In the next few minutes, we will uncover the secrets of what makes up our universe. What is this unseen substance? How do we know it's there? And how can we find it? Let's take a deep dive. In the 1930s, astronomer Fritz Zwicky noticed that galaxies and clusters were moving far too fast. According to physics, they should have flown apart long ago. Something unseen was providing gravity to keep them together like an invisible glue. Zwicky named this mysterious substance dark matter. But today, scientists think dark matter is much more than a mere glue that holds things together. In fact, they believe that it makes up 80% of all the mass in the universe. That's right, 80%. So if it's so important, why is it invisible? Because dark matter doesn't emit light, doesn't reflect it, and doesn't interact with normal matter. It's like a ghost that only reveals itself through its gravitational pull. How did scientists come to this conclusion? By looking at the effects of gravity on visible matter. For example, stars at the edge of spiral galaxies rotate faster than expected. Computer simulations show that if dark matter didn't exist, those stars would simply fly off into outer space. Same goes for galaxies and clusters. They stay together despite their immense speed. Dark matter seems to be holding them all in place. This is where things get a bit complicated. Scientists don't actually know what dark matter is made of. One popular idea is that it's made up of exotic particles that we haven't detected yet. These hypothetical particles are called WIMPs, which stands for Weakly Interacting Massive Particles. Another idea is that dark matter might not be made of particles at all, but a hidden force similar to gravity. Maybe dark matter isn't a substance, but a property of space. All of these ideas and more are being tested in laboratories and observatories around the world. For decades, experiments have searched for WIMPs using huge underground detectors shielded from cosmic rays and other background radiation. But so far, they've turned up nothing. Some scientists even hypothesize that dark matter could be made of primordial black holes, small black holes that formed in the early universe. Primordial black holes would not interact with regular matter, explaining why we haven't seen them. They would also create a gravitational pull that could explain the effects we currently attribute to dark matter. However, scientists have yet to find evidence of primordial black holes, leaving the question of dark matter still unanswered. So what does this mean? Does this mean dark matter doesn't exist? Not necessarily. Scientists are coming up with new and exciting ways to detect dark matter. Some researchers are exploring the idea that dark matter could be explained by a modification of Einstein's general relativity, his theory of gravity. This would require new physics and a change in how we understand the universe. Others are searching for WIMPs using new methods and more sensitive detectors. Experiments like the Xenont in Italy, the Pandax experiment in China, and the LZ experiment in the United States are pushing the boundaries of what we can detect. Deep underground in the South Dakota gold mine, scientists are building the Large Underground Xenon Experiment, or LUX, when it comes online in the mid-2020s. LUX Zeppelin will be the most sensitive dark matter detector ever built. It will use 10 tons of liquid xenon to search for WIMP. The goal is to find a particle that has a mass about 30 times that of a proton and interacts with ordinary matter about 10 times more frequently than expected. If successful, it could confirm the existence of WIMPs and revolutionize our understanding of the universe. But what if scientists discover that none of these ideas are correct? What if dark matter isn't a substance at all? This might mean that we need to develop entirely new physics, a theory that explains how gravity works on the smallest scales. Such a discovery would open up a whole new era in physics and would likely earn the scientists involved a Nobel Prize. But wait, there's more. There's another mysterious substance called dark energy. As you may have heard, our universe is expanding. Galaxies are racing away from each other. Wait, that doesn't make sense. Why are they moving away? Shouldn't gravity be pulling them together? It's like if you let go of a rubber band. It springs back. But instead of springing closer together, galaxies are springing farther apart. in the 1990s. Astronomers were trying to figure out if the expansion of the universe was slowing down due to gravity. They were expecting the universe to be a bit more like that rubber band, but they got a big surprise. Instead of slowing down, the expansion was speeding up. It's almost as if there was some kind of repulsive force pushing the galaxies apart. Scientists called this mysterious force dark energy. It's like there's this invisible barrier between galaxies that keeps them from falling into each other. Here's how it works. Imagine you have 3 galaxies floating in space, just like a duck in a bathtub. Now, turn the water on and watch what happens. Those galaxies are like the duck, bobbing along in the current. But instead of water, the universe is filled with dark energy. And instead of a tub, the universe has no boundaries. The dark energy is pushing the galaxies apart, not because they're close to each other, but just because they exist. This means that the farther apart 2 galaxies are, the more dark energy is pushing them apart. Right now, dark energy is winning the battle against gravity. But it might not always be that way. In the distant future, gravity could overcome the push of dark energy and start collapsing the universe. Or maybe dark energy will continue to push the universe apart, causing everything to disappear into a cold, dark abyss. But here's the mind-bending part. Together, dark matter and dark energy make up 95% of the universe. Everything we know, stars, galaxies, atoms, even us, makes up less than 5%. In other words, most of the universe is a cosmic blank space. When you think about it, it is pretty amazing that we can observe such a small fraction of the universe, and yet we've been able to learn so much about it. We've mapped the distribution of galaxies, discovered supermassive black holes, and explored the atmospheres of planets beyond our solar system. But there's still so much we don't know. Here are the biggest questions we're trying to answer. What exactly is dark matter? Is it a new kind of particle? A hidden force? Or something else entirely? What is dark energy? Is it a property of space? Is it something we can't even imagine? And how does dark energy relate to dark matter? Could they be different aspects of the same phenomenon? And finally, why do we need dark matter and dark energy? Could the universe work just fine without them? The answers to these questions could revolutionize our understanding of the universe and our place in it. Here's what we know. Both dark matter and dark energy seem to be evenly distributed throughout the universe. They're also both completely invisible. We can only observe their effects through their gravitational pull. This means that to detect either one, we need to look at how it affects other things in the universe. To detect dark matter, scientists are building increasingly sensitive detectors on Earth and in space. These detectors are designed to pick up the faintest signals from dark matter particles. Meanwhile, to detect dark energy, scientists are turning to telescopes. They're looking at the distant universe to see how light is being affected by dark energy. This could help them understand how the universe is expanding and how that expansion is speeding up. The race is on to detect dark matter and dark energy. And when one is discovered, it could open up a whole new era in physics. It could also help us answer some of the biggest questions we know, like, are we alone in the universe? To learn more about this, you can watch our video on the Fermi paradox. What do you think is the biggest mystery in science? Let us know in the comments below. And don't forget to hit subscribe. Thank you for watching!